Hi class, in this video we're going to continue working on our menu application, and in the last video we talked a little bit about using the comparable interface and the compareTo method, and we want to implement a little bit of that in our menu item. But before we do that, we need to create a class to inherit our menu item class, because remember it's abstract, so we can't create an instance. Let's take a quick look to remind ourselves what we were doing here. Our abstract class name is MenuItem. Again, to make a class abstract, we just put the keyword abstract between public and class. We defined our fields, and then we used some nice handy-dandy utilities in NetBeans to generate some code for our default constructor, our all-parameter constructor, some getters and setters for our different fields to expose them as properties. Then we added a method to calculate an item profit by just taking the item's price minus its cost. And we created an abstract method to say that anybody that implements our class has to include this GetPrepTime method in their class. The GetPrepTime method is supposed to return a float value, and it should accept a parameter that is an integer. There'll be the number of items that we're wanting to prepare of that item type. So if we're going to cook 100 hamburgers, it might take a little bit longer than just one. Okay, so to make this an abstract method, we include the abstract keyword, and after our parameter list, we end the statement with a semicolon. We don't have any curly braces, no code body associated with our abstract method, so it is a method definition that ends with a semicolon. All right, let's use our class. I'm going to look at my projects here, and I want to add a new class file to our project. So I'm going to create a new Java class, and I'm going to name this one MainCourse. Now I'm going to go ahead and finish. And I'm going to create some class documentation. It would be helpful if you would do this for every class object that you create, unless it's such a minor little helper class that you don't think it's necessary. But when we look at our Java doc, you'll see that this is carried forward. Let me continue here with our date, and I'm going to put today. Try to remember it's 2017. This class will define a main course menu item. So I'm thinking main courses of, like, you know, spaghetti or meatloaf or things like that. I'm not thinking of, you know, steak and mashed potatoes. So to me, the main course would be the steak. So I don't work for restaurants. So this is one of those areas where, because I didn't consider talking to customers, I could be using a little bit different of a terminology than they might, but I think we'll be okay, because I'm going to hide this in this class code, and they shouldn't see that, and we'll be able to change things. So I'm creating this main course. What's it going to do? It's going to extend our menu item. So now it has become a child of our menu item class, and right away the IDE is complaining, and if I mouse over it says main course does not override abstract method GetPrepTime in our menu item class, and so we're already getting an error. Because we define that abstract class in our menu item class, we have to implement it in the classes that inherit from our menu item. So we will do that. Now, for our main course, we're going to add a private field. I keep using those floats, don't I? And this is going to be main course prep time. and I'm going to initialize that to 0. And I want this field because we're going to have to implement that method to calculate the prep time. So as we continue developing our application, we could fully implement that. I'm going to go ahead and create some constructors. And I want both the menu item and the menu item with all of its parameters. So I'll generate that. And then let's take a look at that. In this case, it might be beneficial for you to go ahead and type that code because it is kind of unusual. And so I want you to make sure that you feel very comfortable with it if you're going to generate that code using the IDE. I'm moving my variable, my field, back up above. Now, in my main course, I'll go ahead and create some documentation. /*, enter, and this is the default. This constructs a default main course menu item, and then for our constructor that includes all of the data fields, /*, and it generates all of our parameters for us, which is super handy. We'll say this constructs a main course menu item using specified values. So that takes care of our constructors. We need to create some getters and setters for our field here because we do have this field. So I'm going to go ahead and insert code again, and I'll do a getter and setter. And I'm going to click encapsulate fields. And then I have some getters and setters. Notice that when we use that insert in that way, it didn't generate comments for us. So we're seeing that, some of the helpful tools give us a little bit more help than others. So return, I think this is how they would look, return main course prep time, and not super helpful. I know you would add more meaningful comments if you were creating a system. But in this case, we need to hurry. So we're going to say update main course prep time with supplied parameter. So now our class here of main course is almost fully implemented. We have one small problem in that we haven't created the method GetPrepTime. So let's go ahead and create that. I'm going to put it at the bottom. We said that it needs to return a float. And notice that this is a different method than our getters and setters, because in effect it appears like we're doing the same thing, but we're not, because this GetPrepTime is going to require an integer parameter with the number of items that we're going to be prepping. So we're going to return our main course prep time times the number of items. We can make it this if we want. And now it looks like our class is fully implemented. We have everything except a comment here. So returns the estimated prep time of a supplied number of items. See if I can close this area. That's a little better. Okay, so that was our last method that we included. Let's review our constructors. When we create a child class, when we construct that instance of that class, we're actually going to be constructing an instance of the parent or superclass first, and then we'll be extending that parent class to construct this instance of the child. So when we are specifying parameters, all of our data items, we want those to be parameters to our main course constructor. They have to pass them to us to build this item. But then as soon as we receive them, we're going to pass them on to the parent, to the superclass, and say, here, go ahead and construct like a hidden instance of yourself for me to be dependent upon. Because remember, we can't have children without parents. Not always good parents, but we can't have children without parents. So we construct an instance of the superclass, and then our child class instance will be created in memory. Now, we would like to set up some parameter defaults for our main course, and we'll come back and do that here in a minute. First, I'd like to go ahead and go back to our the menu class, our main, and this is our tester. And so in our tester, I'd like to create some instances of these main course items so that we can take a look at how things are working. So in my main, I'm going to create an array of objects, and we're going to call it objects. That's hard, huh? And we're going to say this is a bunch of new main courses. One main course and another main course. Okay, so as we construct this array of objects, we've got our two main course objects inside there. They're both empty right now. So we're going to go ahead and put some data in there. So what I'd like to do is be able to say, oh, this main course item in the objects array, can I say objects sub-0 dot set item name? Because this is an array of main courses, and my main courses have a set item name method. But no, Java doesn't like it. Because this is an array of objects, it's too general. It's too general for Java to find us a specific object type. So we're going to cast this, and we're going to say, Java, this is a main course. And in this main course, I would like to run the set item method, set item name. And let's see, the first main course I'd like to have is steak. And I apologize if you don't eat meat. We'll do a vegetarian one next, okay? Now, in our main course, we need to set up some more default fields because we didn't specify any of that information when we created these objects. So I'm going to set item description. Ooh, I've got some stuff downloading, don't I? It's happy. We'll say this is a delicious T-bone steak. And don't be mad at me because I can't eat steak anymore. So sometimes I think about it. All right, our next main course field that we want to set in this main course, our 0th one, our first one in our array, is going to be our item cost. And I want this item cost to be, let's see, how much is this going to cost us? About $20. And if you notice, we get an error because as incompatible types, it says it's a possible lossy conversion from double to float. So by default, when I specify a number in a parameter like this with a decimal place, it's a double data type. One thing that I can do is, again, cast. I'll cast this one as a float. Now, our item price is also a float, so we'll look at another way to handle that. So when I set our, set our item price, it's really mad at me about this JavaDoc stuff. Now again, I want this one. Let's see, we said we're gonna, it costs us $20, so I guess we'll sell it for about $100. We don't have a cheapo restaurant here, we're pretty expensive. Alright, is it gonna give us an error? Finally. And there's another way I can turn that into a float. Remember, I can use the format specifier, the uppercase F, and say this parameter is really a float object. All right, that creates one instance of our main course with some values. I'm going to copy this. Now, if you copy and paste, we're setting up the values for our second menu item that's in our objects array. So we need to make sure we change this index value, our subscript. We're at item number 1 instead of item number 0 in our objects array. And let's see, this one will be about vegetarian pasta. Is that a thing? I hope so. And our description is going to be vegetables and pasta. Now for our cost for this one, it's going to cost us $10 and we're going to sell it for $1.50. And the reason I want to do that is because when we add our sort, maybe we'll want to sort on our profit. Who knows? Alright, so we've created all of our array entries. Now let's output those. I'm going to use a for loop, not with an uppercase F. So I'm going to set up an integer named I and start with it equal to 0, and I'm going to loop while I is less than my object's array length. And I'm going to increment I. In this for loop, I'm going to go ahead and output this object. Now let's see what kind of output we get from that. I'm going to run it. So what we see by default is just a standard object ToString output. It says the menu.MainCourse, and it tells us some sort of memory location there for where this class is instantiated, and that's not what we want. We want the ToString output that we created, our overridden ToString, and we can say, let's go ahead and cast this then as a main course so that we get the right output. Let's try that. Maybe we should just say, oh, this is a menu item. Is that where we put our ToString? Let's see. Nope, still not overriding it. Got some sort of problem there. Let's take a look. So here's my menu item. Looks like in my enthusiasm for doing our video, I left that out. Let's put that in. So after our GetPrepTime, I'm going to do a public string, ToString, to override the default class ToString, because all we're getting is that information that might be super helpful to a programmer, but our users maybe wouldn't like to see it. So what I would like to output, let's say we're going to output our item name and a space and our profit. How about that? I'll put a comment. I see a couple I'm missing. Override the system ToString method. So every object in Java by default has a ToString or implements the object class ToString method, and we can override that to output what we want in our class. It's complaining it to me. It says you don't have the @override. Now remember, the @override isn't required, so I leave that out to remind you, but it's recommended because that way if there is some sort of problem where you're not overriding something, you'll get a warning from Java. I'm going to go ahead and put a comment here on our abstract method. This method calculates the prep time and is required. Okay, let's run this again. Very good. Now we're seeing that steak, our profit is 80, and our vegetarian pasta, our profit is 140. So we want to implement that comparable interface so that we could sort this array of menu items. And we're going to go ahead and do that. I'm going to start with my menu item class. And I'm going to find that class definition. And I'm going to say, hey, my menu item class, I want it to implement the comparable interface. And what it's going to compare, are menu items. Now, we don't have any sort of problem here. Everything's happy. But if I look at our MainCourse file, scroll up to our class statement, we should see that we've now gone into an error condition because we don't implement the compareTo method. So we've got to put that in here. Now, notice how I put it in our parent class, the implement clause, that we implement that interface. But I'm actually going to implement the method, the required method, in my child class, in my main course, because it gives us a lot of flexibility here that we could implement this however we want in different children. So let's do it. I'm going to put in the @override. Remember, I'm going to return an integer from the compareTo, and what I'm going to be expecting as a parameter is a menu item, which in this case is going to be a main course, that I'm going to refer to as O. So oftentimes when we just use a object as a parameter, we refer to it as O. Now, why is it mad at me? We'll see. Now, in my compareTo class that it's mad at me about, I'm going to go ahead and code this and see if everything, kind of eventually gets cleared up when I compile. I want to compare the profit. So I want to say if this there it is, calc item profit is greater than O's calc item profit, then I want to return 1, right? Because my object is greater than the object I'm comparing to. Else, if this calc item profit is less than O's, it's going a little wacky, calc item profit, I'm going to return -1. Otherwise, I'm going to return 0. They must be equal. Now, I said it's a little mad at me. Let's see if we could run and it gets over it. I might have to put a default signature in for the compareTo in our menu item. I think I'll just go ahead and take this implement out and put it in our child class. Oops. So, our main course is extending MenuItem and implementing the comparable interface. And in our comparable interface, we need to specify what kind of items we're going to be comparing. We're going to be comparing main courses. And is everybody happy? Everybody's happy now. Okay, I'm going to go back to my menu and update to sort. Before our first for loop, I'm going to go ahead and output a line. And then I'll do one. And let's put in our sort. So we're going to say java.util.arrays. Oops, it went a little crazy on me. Sort. And we want to sort our array of objects. Now, to output our objects, we're going to use a for loop, but we're going to use the for each implementation, so it'll be a little different. So I'm going to say for an object named item within an array of objects named objects. I would like to do this code. I would like to do system.out.println. And again, remember we had to cast our object before. So I'm going to cast it as a menu item. So the syntax is for, in parentheses, the data type of the array, then a name you want to give to each entry in the array. So each entry in the array, as it's processed, is going to be placed into this variable named item, then the colon, and then the array name. So it's a for each implementation. So for each item and objects, I'll execute this loop, and I'm just going to print them out. So let's run this again. Looks the same. We got to change some prices here. So I'm going to make my veggie stuff cost, how about $15? Let's run that again. Now we see that it sorted our items into a different order. Great. I'd like to do one more menu item in our array. In our new main course. And for this main course, we're not going to specify any parameters, and we're not going to use any setters to update those values. So I'd like to update our main course class to set up some defaults in case somebody does that. So we're going to go back to our main course class, and we're going to find our constructor. And I'm looking for our default constructor. In our default constructor, I'm going to add one line of code, and I'm going to say, hey, for this object, go ahead and run the constructor that expects parameters with these values. So we'll have default main course is our name, default main course description, then I need my cost. Let's say for our default we're going to send $1, and for our price we're going to send $1. So this should end up being a profit of 0 so that it doesn't cause any sort of problem with our profit analysis. So how are we? What's it mad at me about? Strings cannot be converted to float. Okay, so if I have things in a different order, we'll be in trouble. So let's see, I've got item name. Oh, I do. Then item price. Then item cost. And then the description. That look better? Okay, so our parameters are in the correct sequence. Now, we're saying that if somebody creates an instance of a main course object and doesn't supply any parameters, we're going to use these defaults. And why did we do it this way? Because that way, if our main course constructor that establishes our data values, we don't have to duplicate that code, right? So we're just running our same constructor here. So instead of running the constructor with no parameters, our no parameter constructor is going to run this one. And then it's going to run this one. So we're going to have some constructing going on, right? All right, let's run it. Okay, so now we see our objects before our sort. We have our steak, vegetarian pasta, and a default main course. Then after our sort, our main course is sorted to the top. Then our pasta, and finally our really expensive steak. So looking at our profit, we're seeing our profit increase. That's really what we wanted to do in this project for now. So we've seen how we could implement an abstract class with an abstract method. we've created an inherited class, and in that inherited class, we implemented the comparable interface so that we could sort it. Now we could create our own interface also. So if we create our own interface, we're saying basically that everybody has to follow our rules again, that we don't want things just going rogue, you know. So let's do that right before we're done. I was thinking we're done, but we're not. All right, in our menu, I'm going to right click on the menu and create a new Java interface. I'm going to call this interface iMenu. And in this menu interface, we're going to put all sorts of different methods. If we liked, we might be able to say that, hey, anybody who implements my menuing system class must include this method that calculates the number of calories or something. I don't know. We can do all sorts of different things. All right, so this is our interface. So all we need is the keyword public interface and then our interface name. And in our interface, we just implement some sort of method that we've decided all of the classes that inherit from us or implement our interface must have. So we're going to make ours be a string output, and we're going to call it print description. Because, you know, in our default to string, we ended up printing our profit, so maybe we would like to get our description out, or maybe we want to print everything. We'll just call this one print description. So I'm going to declare this. So it looks a lot like an abstract method declaration, except that I don't have the keyword abstract, and I'm saying anybody who implements this interface must create this method print description, and it must return a string. Now let's go to our menu item, our parent class. In this one, we really can implement this, and this is where we want it. It implements iMenu. And do play a little bit with the interfaces. We can implement more than one interface, but we can only have one parent class. So the use of interfaces allows us to be a little bit more flexible in determining what kinds of methods our coders need to implement in their code. In this case, our menu item implements that. So I'm going to go look at our main course. And our main course again is now flagged an error because it doesn't override abstract method print description. So let's go put that in. I'm not necessarily going to use it at this point, but I want you to see how as soon as we create it, we're back okay. So public, it's going to be a string, print description. And in our print description, we're just going to return item name plus a space plus the item description. Now, it's giving us an error again because I'm accessing some private data items in the parent class. So there's a few different things I could do. Still not letting me, is it? I could use the get item name. Another thing that we could do that they do talk about in chapter 13 is we could go to our parent class, our menu item, and change our data fields from private to protected. If you remember from your reading, protected means no code outside of this project would be able to access these fields, but classes within the project can. So if we do that, and then go back to our main course, you should see that we're fine now. Because we're part of the same project, we're able to access those protected variables. Again, like I said, we're not going to necessarily run that one. I'm going to run my program one more time, make sure I didn't get anything upset, even though I'm not going to test that. And everything looks great. Okay, I hope to use this menuing system as we progress through the semester so that maybe we can change our input to be forms-based if time allows. We see what happens. But I hope that this has been helpful for you in understanding some of these more advanced concepts.